Thanks for tuning in. My name is Brandon Clayton, the Algebra Guy. As you see on your screen, the discussion will be over how to solve percent increase and decrease problems. Along with talking about percent increase and decrease, we will also discuss how to translate and solve basic percent equations and how to solve application problems with percent in them, like the word problems that you tend to see. So here's our first question. When Alana and their friends went to eat dinner at a restaurant, the bill came out to $80. They wanted to leave a 20% tip. What amount should they leave if the bill is $80? Now, this is a typical question that you could get as adult or anyone at a restaurant wanting to leave a fair tip. Not wanting to be cheap or maybe go too far over. So how do you work this? So the first thing to do that's very important is identify the question that's being asked, and let's rewrite it. So really what we want to know is what is 20% of $80? So what dollar amount, I could have said that, what dollar amount is 20% of $80? So what is, so that's the part we don't know. What is the dollar amount? I can put a little dollar sign here so I remember. Is usually an equal sign, 20%, and that's our decimal, of times $80. Times 80. So when you look at it this way, you should think of what you can do to solve it. It becomes pretty simple. 0.2, I made that dot pretty big, looks like a multiplication dot, but this is 0.20 times 80. So if I get my trusty calculator out, and you could probably do this in your head with some, I don't want to say cool tricks, but if you could think about this in a different way, I can show you some ways to work this more quickly. Because I wouldn't do this on a calculator, I just do this in my head using what I call the 10% rule. But if I'm going to use this, I can do 0.2 times 80, and it'll tell me my answer. So they'll need to leave a $16 tip. So in this case, X, my amount of money will need to be $16. And this is like a bonus. I didn't actually intend on teaching this, but I can't help it because I don't do it this way. This is more arduous, especially for an easy round number like 20%. So what I would do instead, let's erase that. And what I would do instead, if I'm looking for 20%, so I have 80, right? I know what 10% of 80 is because I know that you can divide by 10. Let's put 10% here. I know if you divide by 10, you move the decimal one place from here over to get 8. So I know that 10% is 8, and so 20% is going to be double that, which is 16. So that's how I would have done it in my head. That's just a little bonus there, but not necessary in working these problems when you can do it by hand and use your calculator. So maybe we'll go over that another time. What is 35% of 90? So again, it's important that we set this up. What number, we don't know, we're going to make that X, is 35%, that's a decimal, of, that's multiplication, 90. So there is our equation right there we need. And we can just pull up our calculator or do it by hand, but to save time, we're just going to use our calculator and do 0.35 times 90. And that gives me 31.5. So 31.5. What is the number? What number is 35% of 90? Well, 31.5. That makes about sense. That's about a third of 90 is 31.5. So we always want to kind of check our answer. That makes sense. Let's go to our next one. Let's try this one. Now, I encourage you to try this one. 125% of 28 is what number? So let's rewrite this into an equation that we can solve. First, let's change our percent to a decimal. 125 is 1.25 of times 28 is, that's equal what number? So we're going to make that X. And there it is again. There's on our equation we can use. What number is 125% of 28? So I can just multiply that out and find it out. So I'll get my calculator. I'm going to do 1.25 times 28. And it's 35. And does that make sense? So we got X equals 35. Does that make sense? Well, we got 100% of 28 will be 28 because that's everything. But more than 100% will give us a number bigger than 28. So that makes sense that it's going to be bigger. So that looks good. All right, translate and solve this. 36 is, and I would encourage you to pause it here and work this, but 36 is 75%, 0.75 of what number? Of some number. Let me make a multiplication dot there, of some number. So now this isn't straightforward where we can just multiply two things now. So now we have to look at this and solve for x. And if you remember how to solve, we're going to get x by itself. Since we have multiplication, we're going to divide by 0.75. And that leaves us with x equals 36 divided by 0.75. And let's figure out what that is. So 36 divided by 0.75, 48. So 36 is 75% of what number? That's 36 is 75% of 48. All right, 6.5% of what number is 1.17? Again, pause it and try to work this and see if you're getting the same thing I am. First, I'm going to convert this into a decimal by dividing by 100, moving this 2 spaces back. When I do that, 1, 2, that gives me 0.065 of, that's times, what number is 117? So again, I need to do a little bit of math here by dividing 0.065 to get rid of that. Do it on both sides. This goes away, leaving me x equals whatever this equation comes out to be. So let's use our calculator and do 1.17 divided by 0.065, 18. Let's look back at the question and see if it makes sense. 6.5% of what number is 1.17? So that makes sense because we're taking a really small percentage out of 18 and it's only 1. So that does make sense. What percent of 36 is 9? What percent? We don't know what this percent is of 36 is equal to 9. So I want to know what this percent is. So what I can do is isolate that x by dividing by 36 on both sides. X is now 9 divided by 36. So I'm looking for the percent, remember? So I'm going to put that in my calculator. And remember, I'm looking for a percent. 9 divided by 36. And there it is. Since this is 2500ths, 2500ths, we remember is the same thing as what percent? 2500ths is the same thing as 25%. So the really key to these is setting it up and translating it correctly so that you can simply do your algebra. 144 is what percent of 96? All right, again, we're going to isolate this x by dividing 96 on both sides. And it gives us x equals 144 over 96. So 144 divided by 96 is 1.5. What is that as a percent though? So this is 1.5, but they wanted a percent. So to get a percent, I need to move this to move this decimal 2 spaces over like that. And that translates to 150% or 150% looking like this. All right, so what about word problems like this? We just talked about a tip. Dayson and his girlfriend enjoyed a dinner at a restaurant and the bill was $68.50. They want to leave an 18% tip. 18% tip. So really the question is, what is 18% of 68.50. So we wanted to put it in a way that we can clearly write an equation for like we did before. So what is, we want to know this dollar amount. What is not equal sign 18%, 0.18 of 68.5. So I already know that. So all we got to do for this one is put in our calculator. And that's going to give us 0.18 times 68.5. So what is 18% of 68.5 is going to equal $12.33. The label of Masio's breakfast cereal said that one serving of cereals provides 85 milligrams of potassium, which is 2% of the recommended daily amount. What is the total recommended daily amount of potassium? So right down here, if you look at potassium, it says it's 2% of our daily amount. So this 85 is 2%. Well, if that's 2%, then what's the 100%? What's the total of our daily amount? So that's really the question. What 2%, let me write it that way. 2% is what part? I'll write it differently. 85 is 2% of what total? That's an easier way to write it. So 85 is 2% of, that's the times, what total? So we're going to get this x by itself by dividing by 0.02. Dividing by 0.02. And that leaves me with x equals 85 divided by 0.02. And what is that going to give me? 85 divided by 0.02. It's 42.50. So to answer our question, 4,250 milligrams must be our daily allowance, or the daily what do they call it? The daily amount, recommended daily amount that we should get. 2% of that would be 85. So now we know how much they're recommending that we get every day. So it's cool that you can work backwards when you know how to set it up properly. Missy received some gourmet brownies as a gift. The wrapper said each brownie was 480 calories and had 240 calories of fat. What percent of the total calories in each brownie comes from fat? So they asked a great question there. What percent of the total calories, which is what? The brownie said they 480. What percent? This is multiplication of 480 is 240. So we want to know how much is this piece compared to the whole thing. What's the percent? So what percent of the total is 240? Well, let's find out. Let's get that x by itself by dividing 480. Dividing 480. And when we divide, those two turn to 1, so it's just x. 240 over 480. And it looks like it's just half. Because, yeah, half of 8 is 4, half of 4 is 2. But I'll put in the calculator just to make doubly sure. Bam, 0.5. So 0.5 is the same thing. If I add a 0 for the placeholder, we'll see that that's the same thing as 50%. 50%. 50%. So you can tell somebody, oh my goodness, this brownie is half of it is the calories of fat. So it represents half the calories come from the fat. Oh my goodness, don't mess it up for me, somebody might say. But you can do the math and figure that out. What about percent increase and decrease? Well, to do percent increase and decrease is really simple. First, you just need to find out how much is increased or decreased and divide it by your original amount. So that's what I have here. To find the increase, subtract their new minus the original. And divided by the original amount. So let's look at that. For instance, in 2011, the California governor proposed raising community college fees from $26 to $36. Find the percent increase. We're going to round to the nearest tenth. So we went from 26 to 36. So how much did we go up? So we just do 36 minus 26. That's how much we went up, right? And we're going to divide that by what we started from. We went from 26. That's where we started from. That was our original. So when we do the math, we end up getting 10 over 26. And what percent is that? Well, again, we can just plug that into our calculator. 10 divided by 26 is this percent here. We're looking at the hundreds place. That's 38%. So they wanted to round it to the nearest tenth of a percent. So this is going to be 38.5% because we're going to go over one more. 38.5, 100. So this would be 38.5%. So they didn't say 10th place, which would have been the 3. They said 10th of a percent. So we have to look at the percent and go over another one because we had 38%, but we move over one more space and look at the 4 because that's going to give us our 10th place there. We raised it up because it was a 6, and that's greater than the 6 is greater than 5, so we raised that 4 up to a 5. So it's 38.5%. Average price of a gallon of gas in the city from 2014 was $3.71. The average price in the city in July was $3.64. Find the percent decrease. We're going to do the same thing. So we started at $3.71. Then it was $3.64. What was the original we started at? It was $3.71. How much did it go down? Well, let's just do the math again. If we put that in a calculator, 71 cents to 64 cents. It looks like it's 7 cents, but since I have my calculator, let's just work it out. Nope. 3.64. 7 cents. So that's 0.07371. So let's divide that to figure out what percent that is. What is 0.07 divided by 3.71? And we look at those first two spaces, these to the hundreds place, and it looks like it's going to be 1.9%. Like if we rounded that up, that's 1.886. But if we rounded it up to the nearest tenth place, it would be 1.9%. 1.9%. So there was a 1.9% decrease in the prices of gas. And that's the only difference here with increase and decrease is you have to remember that you're going down and actually say we're going to 1.9% decrease. Did we answer our questions? How to translate and solve basic percent equations? Yes, we did. And the translation part is the biggest piece, please. Remember that the of is your multiplication, the is your equal signs. You got to translate those percents back to decimals, and it really makes the problem for you. How to solve applications. We show some realistic type problems, even looking at calories and food, and how to find percent increase and decreases what we just did. Guys, thanks for tuning in again. My name is Brandon Clayton and the Algebra Guy, and I will see you next lesson.